Hi, welcome to my series of short videos on networking fundamentals. My name is Sambamurthy and I work for Career Booster Technology, and these series of videos are like I prepared as a foundation for the network protocol testing and other networking courses which I conduct both for individuals and corporates. So this is sort of a prerequisite for my training. So I really suggest that go through them and see them as many times as you want so that your foundations are stronger. These are very simple topics, but trust me, they are very important too. Okay. So in this first video, I'm going to talk about some of the topics of the network essentials, and then the topics are like topologies, communication modes, and number systems, right? So let's get going, and the topologies are of various types. Some of it we must be already knowing it very well, but my idea is to just tell the logic behind each topology, the purpose behind them, and then why they are deployed in certain fashion, why the network elements are connected in certain way. So when I take the first one, which is the bus topology, the idea is very clear, right? Here it is like the physical media on which these are all connected is shared by everyone. And all these devices to that extent are layer 1 devices, if I have to say that way. Which means what? If someone is talking, others have to wait, right? It's like, two humans are talking to each other. So obviously when talks, other listens, and other person talks, the first person listens. So here it just depicts the fact that the physical media is shared, so you have to take turns to use it. Otherwise, it would collide. The data will collide. So that's the idea here. So at a later date or another video, I'm talking of when I talk about hubs, you would realize that that represents the bus topology. The second one, what we are seeing is a ring topology here. Here is the idea is to keep it simple but yet connect everyone to everyone. Like for example, A is connected to B, A is connected to E, A is connected to C via B, A is connected to D via B and C or E and D. So the idea is everyone are connected, but they don't have a direct connection with everyone. Yes, they do have a connection with a couple of neighbors, but not everyone. The idea is keep it simple, is more like a cascading fashion, then you have a return path coming back so that there is some amount of a backup. If, for example, a link between A and B is broken, you have at least another path taking it. If you have the path broken between B and C, the B can reach C to an alternate path. So this is one of the simplest implementation, and connectivity is there, but obviously it is not directly connected with everyone. Then comes the full mesh. This is perhaps the most expensive relatively in terms of the connectivity and the topology wise. The idea here is actually that you are looking for a lot of backup, lot of redundant paths. You can see literally every element is connected to everything else. As a result, from every element you can see almost 4 connections come out. A is connected to B, C, D, E directly. But in case any of them fail, they have an alternate path. So let's take an example of A and B. You are connected to B directly, you are connected to B via C, you can connect it to B via D and via E. And then also further combinations, like A, E, D, B, A, D, C, B, like that. So you have, or A, E, D, C, B. So if you really write down all the combinations, you will see that, someone who has actually deployed this topology has invested so much, which means that the uptime of this network, the connectivity point of view, it is so much of importance to him because the stakes are very high. His whole business or whatever activity he is involved in or whatever task he is accomplishing using an internet connection is of a very high importance to him, and the stakes are very high. So as a result, if the stakes are so high, if it is so important, they don't mind investing. They don't mind investing in sacrificing so many ports just for the sake of connectivity. If someone feels that's a bit of an overkill, maybe on a need basis, some of the devices can have more connection, others are pretty okay to have lesser connection, then it becomes a partial mesh. So the idea behind mesh connection is to have backup. The buzzword here is high availability. That's what it is. Now, if I go to the other topology, this is a tree topology, somewhat looks hierarchical as you can make out. Normally, especially in an enterprise level network, the entire network is broken into a hierarchy. You have a core, you have a distribution, you have an access. You can see the access, perhaps if I consider them as an access switches or access uh, elements. Their idea is to just connect, provide an internet connection or a network connection to a user. The next level is a distribution. Perhaps I may want to implement a lot of features in it, features related to creating number of VLANs or groups, identifying them, creating separate networks for each department based on the department's function or the type of users like voice LANs or data LANs and all that. And also some sort of a security feature, whom to allow, whom not to allow, and not to forget the quality of service, prioritizing a voice packet. Any application which is time sensitive need to be prioritized. It should not be subject to any buffering and queuing and then delaying it. So all such features are typically built in the second layer, or I would say a middle layer. Then comes an element which is perhaps at the core, right? Or you can say root. The emphasis on these elements is all about performance. How many packets it can aggregate and then pass it to the outer world, like an internet. How fast it can do, how many types of subject can go at a time. It's all about performance. So clearly you see that there are some elements which are meant for only giving an access. Some elements are all about controlling the packets, whether to allow or not allow, whether to allow on low priority, high priority. And of course there is an element which focuses on the performance. Last but not least, we have a star topology. Here again, the idea is connectivity. Connectivity to everyone, but not with a backup in mind. Like in a mesh topology also, you are connected to everyone. Here it is not that way. Here the idea is I should have a direct connection with everyone. Because the reason actually is, one is definitely user-to-user connectivity, each element connected to everyone. But in case there is a connection to this particular element, which is normally switched these days, is an internet connection. Everyone need to share. For example, in a small office, home office, you may have 15, 20 users or maybe 30, 40 users. It's still considered a small office. Perhaps you can do with one internet connection, right? And that internet connection is sought by everyone. Everyone want to connect to that particular connection, which is perhaps a router. So you have an element like switch connected. Everyone are connected to that, and that takes you to that particular element. Like another classic example is telephone exchange. All our telephone lines go and terminate in the exchange. Exchange is connected to another exchange, so that second exchange has multiple users further. So we don't have tens and hundreds wires of coming out of our home, right? That's not the way we see it. But that single connection to an exchange ensures a connectivity with everyone. So that's a star topology. Classic example in our future topics is when we come to the switching and then LAN basics, it's all star topology. So all in all, it's a quick discussion of the topologies just to get a simple idea behind them. Okay. So later, whenever we see a particular topology, which I'm going to use it in my courses, you will have that one basic idea. I know why this fellow is using a star topology. I know why is he using a tree topology or a mesh topology, right? So I can get that. So coming to the next topic, so it's communication modes we have. So first one is a simplex, where the device can do only one function all the time. Suppose A is a transmitter, it cannot do receiving, and then B is a receiver, it cannot do the transmitting. So they do only one job at a time, and they can do only that job. So like a mic and a speaker, if I have to just give an example. Mic can receive, speaker can only transmit. Then there is a second mode which is called half duplex. So you have A and B. So where A and B can talk and listen, but they do only one at a time. Trust me, they can do only one at a time. So if A is talking, B listens, and B is talking, A listens. I'm talking about the half duplex here. Then comes a full duplex where the capability is same as half duplex. A and B can talk and listen, but they do it simultaneously. So in terms of throughput, in terms of what do you call the overall bandwidth, if I have to say, even from an end-to-end point of view, user-to-user point of view, full duplex is the best because they don't have to wait for other one to stop and then talk. So they can talk and listen simultaneously. That's a full duplex, right? So whenever we are coming to the later discussion, for example, in hubs it is half duplex, and then we come to the switches and routers, we say it's a full duplex. And by the way, this can be configured. You can deliberately make any device which is capable of a full duplex, you can make it to do half duplex also.